Good morning, guys, and happy new year. Welcome back to this tutorial. And today we are talking about functions, and specifically functions in the sphere of C programming. And I have seen it fit just to remind you why we use functions in our programming languages. There's a reason why this is done. Ideally, when you talk about a function is simply a piece of code that does specific tasks within a program. You can have a very big program, but then you'll have sub-programs, we call them. So a sub-program and a function is actually the same thing, or module. You can divide a big program into smaller chunks for easy manageability, for easy in terms of reusability of the course and many other things. Reusability of the code. So just as you can see on my screen, one of the benefits of using functions and programs that there is what we call code reusability, meaning that anytime you want to do something that a given function performs, you don't have to actually write that code again. So what you need to do is simply call the code. You do what you call code reusability. You recall that code. Say, at some point I had defined this function and I need it here, so you simply call that function, and that would, of course, would actually even reduce your development time. Then we talk about improved readability of the code. That is to say, you have arranged your code in a manner that this portion does this one, this portion does the other one. So it is easy to read your code and understand how the code is flowing, rather than when you have one big amorphous. It's like you're given, you've seen how a hole, maybe a multipurpose hole, looks like. If someone is sending you to the multipurpose hole to pick probably a seat or to pick some item, the description might be very difficult because there are no things to refer to. But if that multipurpose hole is divided, probably you have rooms, maybe to go to room number R50 and you would find, it's very easy to track that. Then modularity is one of the benefits. Modularity is just exactly what I've just explained, breaking a very big program into smaller bits for easy organization and many other things. Then another point that you need to be aware as we talk about this is isolation of, you can easily isolate a problem. That is debugging. Debugging is simply making your code error-free, remove errors in a program. That is debugging. So it is easy to fix errors in a program that is divided into smaller portions or modules, rather than when you are dealing with an entire, you have a code that has over 2,000 lines of code. It's going to be very difficult for you. But if it is divided into smaller chunks, you can tell where is the problem. It's here. Abstraction, this is a concept that is a bit deeper and higher than this level, but just to mention, to abstract simply means you are hiding some details, that the inner state of an object is not visible to the outside world. Okay, like now you are hiding details within those modules such that it is not available freely for service readers in your program, and many others. So I want to demonstrate how then do we write a program that uses a function. So I will need to launch my code blocks, which I think it's already up here. So we want to write a code And this time round, let's do a program that performs addition. I would want to do it in 2 steps. One, using what we call called function prototype. A function prototype is simply mentioning the name of a function without giving it the return bit. Okay, so I would want to demonstrate practically here, and then you would of course implement it later. The other way is simply defining your function, and then immediately you declare its return. You give us what it is going to do, and basically those are 2 ways of dealing with it. And of course I would want you to look at call by value and call by reference. How is that done? So let's start our program here quickly. Just forgot the steps. Steps are as you have seen on my screen. Say new program, new project, then console application, then you click go, then you come here and say you want to use C, because this platform supports both C and C++. So this is function, or can call it function. Then we just say we finish. So we wait the system to bring us the source code, so that we do. This is now a source code. The source code is simply what you are writing. You understand as a human being. You enter the source code into a text editor. On the other hand, object code is a compiled source code, to give us an equivalent in terms of a machine language, rather something that the machine understands. So now here, I told you that when you are defining your function, the function is always defined before the int main, and we want to do a function that adds 2 numbers. So basically we will have to do it up here and then do everything. We finish up there if the function is not going to be a proto. We are not using a prototype, that is, we will have to declare it here and give it everything here, then we will just come down here. So a function must have the the data type and then the name of a function, of course, added with the arguments. So this is what we are doing. Just say int, and we are going to call it sum, int sum, and then it is going to have the following: int a, comma, these are our arguments, int b, and then because it is not going to be a function prototype, we are going to implement it right here. So let's do this, and then we are just telling that this function is going to return. We can put it in some bracket. A asterisk means times. No, we are adding. So a plus b. This is what we are going to return, and this is our function basically. Integer. Sum, that is the name of the function. You have this argument a, argument b, and we are returning a plus b. Ideally, if you were to say just int a b, when we are doing it at the main here, it has always been, it is fine, but here in this case you will get an error. Okay, so let's leave it like that. So we will come here, and this is where we are just handling our issues of data entry, rather than logics. Logics will be handled up there. So we are going to say here, probably enter the first number, and you know what this is going to do on a new line. So this is on a new line, this one here, reverse new line, and then we would want to say scanf, then you would you must have the code %i, like this %i, because we're going to deal with the integers, but then I need to define my integers here. I have not defined them. Let me just write here. I'm going to have num1 like that, I can copy this so that I don't have to waste a lot of time. Then just copy this, and then I will have it like an num2. Then here I'm saying enter the second number. Enter the second number like that for the second number. So this is to allow us to enter the values, but you see the num1 and num2 have not defined them, so I need to define them here. This is just the normal program, so I am going to have integer, and in this I'm going to have num1, comma num2, num2, and I'm going to have something called add. This is my the one which is going to hold the values for addition. Okay, so once I have done this, I have already been able to tell the user to enter the values, and I have declared my values up here. Down here, I'll need now to say add is equals to. So what am I saying equals to? I'm calling this one here. I'm calling this function. This function is called sum. So I'm saying add equals to. Then I say sum. Okay. Then bracket. I now call this num1. num1 and num2 here. Okay. num1, comma. We have num2 like that. So while we run this program, as it runs, this sum has already been given what it's supposed to return. It's addition. So it's going to perform addition of these two numbers here. I've supplied them here right now. So I'm going to have the last printf, and just say the sum is, let me just use a different with the addition. The addition is, I can have this and that. Then you have %i because it's an integer. So that. Then what you're going to call here is add. Call add. Of course, we have initialized this variable add with passing the function here. Okay, this is actually calling by value. So let's try to run this to see if there's a problem or no when you run the program. So there we are. So let's enter some number, maybe 4. Then we enter the second number, maybe 5. You know that is give us 9. So the addition is 9. And basically that is how you do it without much hassle. Do not hassle here. It's a simple thing. You don't have to cram this, you just have to master how it works. So at some point I think I had mentioned that you can have this down here. You can declare this function to come down here. Please do not do that. You will get an error, because all functions, and I repeat again, all functions should and must be declared before the int main. Even if you must come and declare it down here, because I'm going to show you that. What you are going to do is simply to have up here a prototype. And let me just show you how that will work now using a prototype. This one we were just using function direct. Okay, that is how we have done it. Now using function prototype, it's gonna be very simple. What I'll need to do, I'll just cut this, and then I'll do the implementation after the main function. But up here, I'll need to introduce my function and say insert. Like it has inside it has int a, int b. Then I'll terminate it like that. So I'm telling the function, telling this program that I'm going to use a function sum, and this is how I'm going to do it. So I've declared it here. So let's try to run quickly and we see if it's going to give us a result 3, 3, and the answer is 6. So basically that is it. You have to prototype here, and then you do the definition down